Hey everyone, this is lesson 212 from the Integrated Math 3 book on modeling with parabolas. At this point, you should have some knowledge of parabolas, quadratic functions, how to graph them, more specifically graphing form. Here's a reminder of some information that you need to have. If you already have this in your notes, then you don't need to recopy this. But for the most part, make sure you do understand the graphing form at the very least. You probably already understand orientation, whether it's facing upward or downward. Is it a positive orientation or is it a negative orientation? Stretch factor also will tell us whether it looks skinny or looks wide. The number here will tell us if it's a 4 or if it's a 1/2. That's going to tell us really how much it's being stretched. And then our H and K will tell us shifting left and right or up and down. So, which overall tells us the location of our vertex. All right, so that's a quick run through of graphing form. So what we're going to be doing in this lesson is really just practicing how to actually use equations of parabolas to represent a model of maybe a real life situation. So here is, let me just show you this. I'll just show you the whole thing. So this first of 3 problems I'm going to go over is called jumping jackrabbits. So to clear a 3-foot fence, this rabbit has to start his jump about 4 feet from the fence. So if this is the fence, which is, we're told it's 3 feet tall, he has to start jumping 4 feet away to complete the jump. All right, so I've redrawn it here because I'm going to add some additional lines on it. But for the most part, what we're trying to do is write an equation that models the path of the jump. So something that you need to get in the habit of is really drawing a diagram. So if whether it's in your notes or on a test, if you get a similar problem to this, I would expect some picture that demonstrates what's actually happening as it's described in the problem. So that's one reason why I have a picture of a rabbit jumping over a fence, if we want to call this a fence. So in this situation, when a rabbit jumps over the fence, you'll notice that it actually gives us this shape of a parabola, right? So it looks kind of like these parabolas. So that must mean that there's an equation for the jump. So that could be, we're talking about a jump, but this is very easily, this could be a ball being thrown over a fence. So we're going to write an equation, and what we're going to start with, and I'm going to rewrite this, is that general graphing form that we looked at earlier. So I'm going to put it here. Y equals to a times x minus h squared plus k. All right, so that's the graphing form. We want an equation that's going to look just like this. But what we want to do is replace the a with the actual stretch factor. We want to replace the h with the actual shift, left or right, and we want to replace the k value with a shift up or down. All right, so that means we need to figure out what these values are. So one thing, let's see, I'm going to use, so as usual, if we were going to try to write this out, I want to know what a, h, and k are equal to. And if I know those values, then very easily I could write the equation. So as I look at the situation, do I know any of that information? Well, I don't know how much this is stretched. So I don't necessarily know my A value. H, has it been shifted left or right? Well, the only way for us to know whether it's been shifted left or right is really to know where the X and Y axis is in this picture. So I'm going to add X and Y to this diagram. Now, really, you have a choice. You could put the X and Y axis anywhere you want. But I would suggest putting it somewhere that's meaningful and makes this problem really a lot easier to do. So what I'm going to do is I'm going to put the y-axis really where the rabbit begins its jump, and I'm going to put the x-axis where the ground is, right? Which makes sense. All right, so that means once I have an idea of where my x and y are, right, x-axis and y-axis, then I could figure out where the points are. So, because that's really what we're focused on. So if I want to know my h and k, really I need to figure out where the vertex is in this diagram. So if we assume that the vertex is going to be at the highest point of the jump, right? The highest point of the jump. My question to you, right? If I assume this is the vertex, my question to you is, what is the vertex? What is the h and k? So I'll just ask you for this. What's the vertex? All right, what's this point here? All right, let's see if you got this correct. So we start with our x. So this measurement is going to be 4. And the height, you're like, well, I don't know how high it is. Yeah, we do. We know the fence is going to be 3 feet. So this should be 4, 3. All right, so that's the vertex. So let me write that in. So this is going to be, this point is 4, 3. All right, which means that our h value is 4 and our k value is 3. All right, so technically we have some more information we could use. So what we're assuming is the jump is going to carry this rabbit to this point here. So this is like the landing point, right? So this is where it's going to land. So how we do know, we could assume that there's going to be another 4 feet, right? Another 4 feet away from the fence. And so the question to you is, do we know where it's going to land? What point is this, right? What's the coordinate of this landing point? So this one might be a little bit tricky. So this is 4 feet plus another 4 feet. This is a total of 8 feet. And then height is going to be 0. It's on the ground, so it's going to be 0. Okay, so why do I need to know this point? Well, the nice part here is this is actually an x and a y point, right? In the same way that I call this vertex my h and k, right? We have another point on this graph, which is an x and y. Okay, so let me explain why we need to know this. We don't know what our a value is, and there's nothing on this graph that's going to tell us what our a value is. But if I look at this equation, I notice h and k I just figured out. What we just figured out was a point on the graph, or part of the jump, which could be represented by an x and a y. Well, this equation also has an x and a y. So that means I could actually plug in these numbers. So let me use different color. Oops. So I'll use x equals 2 and y equals 2. So this is going to be an 8 and this is going to be a 0. So if I look at all the letters, right, y, a, x, h, and k, that's a total of 5 letters when I know what 4 of them equal to. Which means I could plug in all these and it's going to help us figure out what a is. All right, so let's do that. All right, so let's start with our y. So y is equal to 0. Right, let me use color so it matches. So we're going to use 0 is equal to, we don't know what a is, right? We don't know what a is. And we're going to have something like this. So this is going to be, we have x minus h. So x is going to be, we said x is going to be 8. And this is going to be, don't forget that minus is always part of the equation. And then we have h is equal to 4. And then we have k is a 3, so that's a positive 3. All right, so we pretty much plugged in everything we have. And you'll notice the only thing missing is the a value. So once we figure out what the a value is, then we'll have enough to write an equation. All right, so let's simplify this. All right, so let's start with, let's say 0. Oops, let me use black. 0, a. So let's focus on the parentheses. 8 minus 4 is 4. So that's squared plus 3. And what is 4 squared? So I'm going to, 4 squared is 16. So this is going to be 16a. I'm going to put that in front of the a now. And there's a plus 3. Okay, so now I'm trying to get a by itself. So let's subtract 3 from both sides. This is going to leave us with a negative 3 equals to 16a, which means that if we divide both sides by 16, we are left with an a value of negative 3 over 16. All right, so now that we've figured out what a is, right, that was what was missing, we have enough to write an equation. And so our equation is going to be, we're going to go back to leaving the x's and y's. So this is going to be y equals to our a value, which is negative 3 over 16, times x minus h, so this is going to be minus 4 squared plus 3. All right, you'll notice we've put our a value, right? Here's our a value, here's our h, and here is our k value. All right, we're leaving x's and y's, needs to stay there if we're going to have a correct equation. All right, so this is what we're trying to do. So what we've just done is we've written an equation for a rabbit jumping over a fence. That is our mathematical equation. So we'll know exactly where, if I could pick like a point like in 6 feet, at 6 feet, I could tell you exactly where that rabbit's going to be. All right, or in 1 foot. In 1 foot, I could tell you exactly how high that rabbit's going to be. All right, that is what we're trying to do. Okay, so let's go on to the next problem. We're going to be looking, for those of you that know something about soccer, or really any kind of sport, any kind of ball that goes flying through the air, this pretty much is the same idea. So we have Kayla, who plays soccer, and she kicked a soccer ball and it traveled a horizontal distance of 150 feet. And it reached a height of 100 feet in the air at its highest point. So first we want to sketch the path of the soccer ball, and let's find the equation of the parabola. All right, so that's what we're trying to do. So do yourself a favor and draw a picture of Kayla kicking a soccer ball through the air and what that might look like. Right, similar to the picture of the rabbit jumping over a fence. Now, when you do your drawings, they do not have to be as amazing as mine. Obviously, you could tell I am a professional artist, and there's really going to be no way you could draw a picture as amazing as this. So, but you could always try, and whatever you could come up with. The goal here, not soccer goal, but the goal is for us to see a picture of really what's happening, and hopefully something that looks like a parabola. All right, so let's create this picture, and we have some information given to us that we probably want to utilize. So the soccer ball travels a horizontal distance of 150 feet. That's how far the ball travels. And it reaches a height of 100 feet. So key information here, how are those numbers going to relate to the diagram? And so make sure you include those numbers. All right, so if I draw in this kick, so the problem doesn't really say anything about kicking it to the goal, but I just added that because it's, I figured if she's going to kick it, she might be trying to score. So let's maybe something like this. Maybe you could draw something better. And let's add some information. So for sure, there's going to be some vertex. There's going to be a point at the top. So the question is really going to be, what's this vertex? So keep in mind, they've told us some information that the ball travels a distance of 150 feet. So from where Kayla kicked the ball to where it lands, hopefully somewhere in the goal, it's 150. Right? So this measurement, let me do this. This is 150 feet. And so let me add, I didn't really add the X and Y axis yet, so let me add those. So I'm going to assume maybe the Y axis is there. We're assuming the X axis is going to be the ground. So question is, what is the vertex? Right? How high? Right? And what's this point? So what's our H and what's our K? So you tell me. What's the vertex? All right, so let's see. This one might be a little tricky. Common mistake is for people to use the 150. Now the total distance is 150, but the vertex is right in the middle, right? Don't forget, this parabola is symmetrical. So I need half of 150. So this is going to be 75. And so how high is the ball? Well, it says a height of 100. So that means that our vertex is going to be at 75, 100. Okay. Now we're going to need to know where the ball lands. So assuming it's going to be over here, let me ask you this. what is going to be this point in the goal. All right. Make sure when you write out your points, you use parentheses, or else it's not a point, it's a list of numbers. So, all right, see if you could tell me what that is, that point. All right, and let's see if we got this correct. So this is going to be 150, 0. All right, so 150 is the total distance, and 0 because it's on the ground. All right, so now that we have all that information, I'm going to move this up. So I like to always list things out. So my A value, we don't know this, right? Just like the previous problem. Our H value is going to be 75. Our K value is going to be 100. And our X is going to be 150. And our Y is going to be 0. All right, so don't forget that this is your X and this is your Y. Just like this is your H and this is your K. All right, so now that we have all this information, all we have to do is set up our equation. So we're going to start with 0. Okay, this is 0. So 0 is equal to A, which is what we're going to solve for. X is 150 minus 75, which is our H. All right. In case you need a reminder here, I'll give us a reminder of our equation. So don't forget, it's y equals to a times x minus h squared plus k. This is what we're trying to build. So let me finish plugging this in. So this is, don't forget the squared, and we're going to do a plus k, which is plus 100. All right. All right, so now we're just simplifying it. So this is going to be 0 equals to a times, what's 150 minus 75? That's going to be 75 squared plus 100. And we want to do 75 times 100. So what is 75 squared, so 75 times 75 is going to give us a big number. So we're at 5,625 A, right, plus 100. Now we could subtract 100 from both sides, and we're going to be left with negative 100 is equal to 5,625 times A. All right, so divide both sides, and we're left with a final A value. I'll switch the sides. So this is going to be negative 100 over 5,625. All right. That does reduce. So if you actually reduce this fraction, I believe 25 goes into both of those. So this is going to be negative 4 over 225. Okay, so most of this work is really just focused on finding the A value. Because once we're done, then we could write our final equation, which is going to be y equals to negative 4 over 225. Let me rewrite this. Equals to negative 4 225 times x minus h, so x minus 75 squared plus 100. All right, and that is our equation of Kayla kicking the soccer ball to hopefully score a goal. So at any point, we could tell where that ball is going to be. Make note of, you'll notice we have a negative number here. Your A value is negative, which makes sense because this graph has a negative orientation. All right, negative orientation. And this fraction tells us that it's going to be pretty wide. All right, so Kayla's not kicking the ball. Kayla didn't kick the ball super high, right? She actually kicked it, well, she might have kicked it high, but it went far enough where it created a wide parabola. All right, and hopefully this makes making more sense. One last problem for us to do, and this one, I don't know if any of you know how to ride a skateboard or have ever been to a skateboard park. This problem has us looking at the U-dip. The U-dip is a parabola that dips 15 feet below the ground. The width at ground level is 40 feet across. All right, so sketch the U-dip and find the equation of the parabola that models it. All right, so here is my drawing of the U-dip. This is the name of, I guess, the portion of the skateboard park where it actually goes underground, right? Probably similar to maybe like a swimming pool, something like that. Or like a half pipe. So make sure you draw your picture. Make it look like yourself or maybe someone you know that knows how to ride a skateboard. And you should have a picture of the U-dip. Now, you should notice right away this one is different than the other two problems because this one actually goes underground, which means this parabola, if you didn't notice, this parabola that it creates is actually positive orientation. So right away you should already know when we solve for our A value, we should end up with a positive A value. All right, so let's add the information that was given to us. So we were told it's 15 feet below ground. All right, so at the bottom, it should be 15 feet below ground. So so we have a choice. I'm not really sure if it matters, but you have your choice. If you want to try it differently, you can, but you could put the y-axis here. You could decide if you want to do the x-axis going straight across like ground level. That's an option. Or if you want to try to figure out really, if you want to pretend the parabola's vertexes on the x-axis, that's another option as well. I think what I'm going to do is I like to keep the x-axis at ground level, so I think I'm going to just keep it there. So I'm going to make this my y, and I'll make this my x. All right, so let's label our points. So I need to figure out where the vertex is. So as usual, and we always want to figure out kind of where we end up. So these are key points we want to use. We never want to use where we began. 0, 0 doesn't help us in this situation, but let's figure out where our h and k are, and let's figure out another point x and y. All right, so in this case, our vertex see if you could tell me what our vertex is. Wait, do we have enough information? Just to make sure that we went over this. 15 feet below ground. So we know it's 15 feet below ground. And the width at ground level, from here to here, is 40 feet across. All right, so I'll add those labels first in case some of you need that. So from here to here is supposed to be 40 feet across. And it's supposed to go as low as 15 feet below ground. So if we were using an x-axis, this would be negative 15. All right, so my question to you then is, what is the vertex? All right, so let's see if you got this correct. So this would be, since this is 40, right in the middle is going to be 20. So this is going to be 20 comma negative 15. 20 negative 15 is our vertex, which makes this x and y point, this is going to be 40, 0. All right, so let's take that information. And use it. So we have, let's see, I'll rewrite the graphing form again. Y equals a times x minus h squared plus k. Letters that we're going to need to know is a, which obviously we don't know. H is equal to 20. K is equal to negative 15. And then x is equal to, we said x was equal to 40. And y is equal to 0. All right, so now that we have all those, we could plug that in and see what this gives us. All right, I'm going to let you tell me what a value is first. So take a minute to work this out, plug everything in. Actually, I'll help you set it up first, and then I'll let you simplify it. So let's see, we're going to have, if we plug in our numbers, so I'm going to start with 0, because that's the y, a, and then x is 40 minus h, which is 20 squared, and then plus k really is going to be plus a negative 15. All right, so now I want you to solve for a and tell me what a is equal to. So after you simplify this, what is this going to be? I'll give you a hint. It's most likely it's going to be a fraction. All right. All right. If you need more time to work that out, pause this. But I'm going to go over the answer now. So this is going to be 0 equals to a times 20 squared minus 15. And I know 20 squared is 400. So this is 400a minus 15. If I add 15 to both sides, this leaves us with 15 is equal to 400a, which means if I divide both sides by 400, I'm left with a equals to 15 over 400. And so the question is, does that reduce? So I know definitely 5 goes into both of those. So I could reduce both of those by 5. And that's going to be, this should equal to 3 over 80. All right. All right, so there's our A value. You'll notice it is positive, which is exactly what we want. So let me see if I could shrink this down. I need more space. All right. And let's write a final equation of y equals 3 over 80 x minus h, which is 20, squared, don't forget the squared, minus 15. And that is our equation of the U-dip, right? That will tell me exactly how to make that skateboard park's U-dip. All right. You'll notice again the A value was positive. It naturally came out positive when we did our calculations because it has a positive orientation. The negative 15 tells us it goes underground, and the minus 20 tells us it was shifted to the right 20. All right. So hopefully you were able to get most of these. Let me know if you have any questions. That's it for now.